Good day, my name is Shama Kisvan, and today I'll be presenting my project report titled Multi-Criteria Decision Making (MCDM) in the Selection of Renewable Energy Sources (VCO method). So, renewable energy sources are also known as alternative energies that originate from various environmental processes. As we all are aware of, there is an increased carbon dioxide emissions and global warming that is caused by the excessive use of fossil fuels. So, there is an urgent need to promote renewable energy sources to meet the growing global demand for electricity, particularly in developed and developing countries. So some of the examples of renewable energy sources includes solar energy, wind energy, hydropower and biomass. So the timeline below shows the usage of renewable energy worldwide. As we can see here, the usage of renewable energy in the year 2000 has been 19% and it has increased to 29.1% in 2022. And it's also become 30% in 2023 and it is expected to be 35% in the year 2025. So, in order to find the suitable energy sources in Malaysia, there are a few problems that we need to face. First one is the high CO2 emission. So, it has been recorded that we are showing a slow progress in cutting the carbon emissions in Malaysia. Next is the missed targets. In 2022, Malaysia produced only 2% of its power from renewable energy sources, and we have an objective to reach 20% of renewable energy consumption by the year 2030. Next is the multiple factors involved. We cannot just simply choose suitable energy sources. There are a few factors that we need to consider before choosing the right energy resources. So some of the factors involved is a technical, environmental, social, and economics factor. The last one is the multiple renewable energy options available. So we have solar energy, wind energy, biomass, and hydropower. So, in order to um, consider everything, I believe that applying the core method within the framework of MCDM will help us choose the right renewable energy sources. So the objectives of my research is the first one is to determine the weights of evaluation criteria for renewable energy sources using the MEREC method. Next is to apply the VICO method as an MCDM framework for ranking the renewable energy sources based on multiple criteria. The third one is to validate the results obtained by comparing with Topsy's method. Next, we move on to the literature review. So, why MCDM? MCDM is used to help select the most suitable options when multiple and often conflicting criteria are involved, which is suitable for this project. So, Abdullah has also have used MCDM to evaluate 15 subcriteria and have found that solar has been ranked the first, followed by biomass. Next, Karasan has also used MCDM method, which is the electric one, to evaluate 6 renewable energy alternatives to find the wind energy to be the first one. Next is MEREC. MEREC is a short form for method based on removal effect of criteria. So what is MEREC? MEREC is a method to find objective weight and it has been introduced on 2021. And the main idea of MEREC is to remove a criterion and see whether it changes its influence and impacts of alternative ranking. So for example, if removing a criterion shows a bigger impact on the alternative ranking, then the criterion is given a bigger weight. Next is the energy applications when it comes to MEREC. Ahmad in 2024 has applied MEREC to design cost-effective hybrid renewable systems and has also integrated MEREC to evaluate locations for solar and wind farms. Next is VICO. So VICO is one of the MCDM methods used to rank alternatives by identifying the compromise solution that is closest to an idea. So it is particularly effective for evaluating renewable energy options where criteria are often conflict. So when it comes to energy application, ZAO in 2023 has used fuzzy VICO to rank projects using 12 sustainability criteria and have found solar PV to be ranked the first, followed by onshore wind and biomass. Next is the VICO for energy prioritization done by Vidya in 2023. She has evaluated cost, efficiency, and social acceptance to find wind power to be ranked the first, followed by hydropower and solar power. So this is the basic framework of the MCDM. The first one is to identify the problem. Second is to determine the requirements. Third is to determine the alternatives. So in our case, the alternatives will be solar, wind, hydropower, and biomass. The fourth is to determine the criteria. We have four criteria involved, which is economical, technical, social, and environmental. And next is to determine the criteria weight, where we'll be using MEREC. Six is to analyze the alternatives. Seven is to apply mathematical models. Eight is to interpret the results, and nine is to make the final decision or final selection. So the first one is to do the defuzzification. So here we'll be using the central defuzzification method. It is important to convert the fuzzy numbers into crisp values so that the next processes can be done. Next is to use the Marek method to find the criterion weights. So the Marek methods consists of six formulas, six steps. So it can be seen here on this slide. So and the third one is to do the VCOM method, where we'll be determining PIS, which is a positive ideal solution, and negative ideal solution. Second is to compute the SI and RI values. Third is to compute the QI values, and fourth is to rank the alternatives based on the values of QI. Uh, to compare the results obtained with the Topsys method, we'll be using the Spearman rank correlation, where when the rho is equals to 1, it is the perfect positive correlation. When it equals to 0, it means no correlation, and when it is equals to negative 1, it is negative correlation. So next is the results and discussion. So here the dataset overview is we have four alternatives: solar, hydropower, biomass, and wind, and we have four main criteria: social, technical, environmental, and economics. And under the four criteria, we have 15 sub criteria. So these are the sub-criteria for the four main criteria. Under technical criteria, we have reliability, efficiency, maturity, and resource availability. Under the economic criteria, we have investment costs, O&M costs, operation and management costs, electricity costs, payback period, and market maturity. For social, we have social benefits, employment creation, and public acceptance. And for environmental, we have land requirement, impact on the ecosystem, and CO2 emissions. So here the table below shows the results obtained after the declassification method has been done. So this is the results on subcriteria weights obtained by using Marek. And the global weight of the subcriteria can be seen here from this graph. Here we can see that C14, C23, and C41 has a bigger weight compared to other subcriteria. So the table here shows the result that we obtained on ranking renewable energies using VCOM method. The smaller the QI value, the higher the rank is. So from here we can see that wind is placed as the first, followed by hydro, solar, and then the last one is the biomass energy. So next is the result obtained using Topsys method. So Topsys method is done to compare the results that we obtained from Vico method. So from here we can see that wind is also placed as the first, followed by solar, hydro, and the last one is the biomass energy. So this is the comparison of rankings and alternatives using Vico and Topsys. So from here we can see that alternative 1 and 2 have a different ranking from VCOM method and Topsys method. Meanwhile, alternative 3 and 4 have the same ranking from VCO and Topsys. So from here, we can say that the Spearman rank correlation is 0.8, which is a positive correlation. So as I mentioned before this, both methods ranked alternative 4 as the first one, followed by alternative 3 as the last one. So it shows that there is a strong correlation, which is the Spearman is equals to 0.8. Meanwhile, alternative 2 and alternative 1 are different for Pico method and Topsys method. So why does this happen? Topsys seeks to identify the alternative that is simultaneously closest to the positive ideal solution and furthest from the negative ideal solution, while VCO focuses more on finding a compromise solution by minimizing the maximum regret. So since the two methods have a different approach when it comes to finding the suitable alternative, That is the reason why we have divergence in the ranking. So the conclusion for the project is both methods consistently identify the same top and bottom alternatives with minor differences in the middle rankings. Meanwhile, merit-based objective weighting enhances the transparency and fairness of the evaluation process, reducing subjective bias. So that is all from me. Thank you.